In this video, I want to discuss how the logic works on the multiple layers that we've created. On the screen, you can see that we originally started with a IDW surface, as you'll recall. That's a floating point surface. And then we've created a series of layers, and we've isolated in each layer the contaminated soil. I can turn them on one by one as I'm doing in the screenshot. And I can see each layer one at a time very easily, but the uh, purpose of the project is to come up with a layer that you see right now on the screen, where every single unique combination has its own color. In the map I'm looking at, if I had a contaminated layer at 3 feet but not at 0 feet, it's one color. If it's contaminated at both of those, it's a different color. If it's contaminated at all 3 layers, it's a third color. And so by looking at that one map, which we'll cycle back to here in a minute, we can see for every single pixel how many layers are contaminated and how many layers are overburdened that needs to be dug up. It just takes kind of a logical jump to understand that. And one of the ways we could think about this whole project is a three-dimensional approach instead of what you see now as a two-dimensional approach. So I'm going to open up ArcScene, which is the 3D viewer, and I'm going to drag these layers into ArcScene and build a 3D visualization. We don't cover ArcScene per se in the class, but it's pretty easy to learn and it's pretty stunning visuals. The program opens like the other Esri products we've seen. Notice it does have a default geodatabase, and so you'd want to get that off your network drive if you're like me and you believe in doing that. You can bring in regular layers. We will bring in, I've converted my 3 raster layers into polygons. The tools we're about to see work a little better with polygons than they do with raster layers. So my areas to dig up, my contaminated areas for my 3 levels, have each been through the model builder process called convert raster to polygon. And I removed the 0 data before I did that. So what I did was I took the values that were either 1 or 30 or 600, and I converted those into polygons. So I have 3 polygon layers, one for each depth. I'm fetching my river now also. So the way the program works, besides color symbolization, the Properties tab allows you to extrude a layer, in other words, to add thickness to a layer, and it allows you to set base heights, which can be constants or they can be a digital elevation model. If we had the bathymetry for this river, we could drop the river surface onto the bathymetry and see what it's really shaped like. So for the example we're going to see here in a minute, I multiplied the depth by 100 in order to get a good visualization. So I have 0 to 300, 300 to 600, 600 to 900 in terms of how thick I'm painting these in order that they show up pretty well. I'll skip ahead here to the final product. Basically what's happening then is I told the layer that extrude from 0 to 300, minus 300, and then the next one start at minus 300 and go down to minus 600, and the bottom one minus 600 to minus 900. After I looked at this, I decided that I wanted to add the river layer in between the depth intervals because it's a little confusing. There's a whole group of tools that you have in the toolbar that let you move this model around. You can zoom to places on the model. You can tilt and plan. You can fly through it the way you would on Google Earth with a fly through. And you notice there's a drop down that lets you decide if you want to extrude up or extrude down or extrude between different things. It's pretty flexible and it's quite intuitive. The file document, so I'm saving my scene right now. It's like an MXD in ArcMap, only this is SCD or SXD or something. So save it, and again, you're of course saving the linkages in the paint job. You're not actually saving the data layers. I've skipped ahead a little bit. I copied the river over and over and over so that I have one in between each layer. I think that it helps me visualize how the layers are stacked and what part of the river they're stacked in. I've brought in my final dig layer, which is the layer that has each of the unique values showing, and I've colored them. So if I'm looking at it in a map view, I would see it this way. And what's happening is the colors are telling me where I have overburden, like example right here where the mouse is overburdened to the layer underneath, but is going to be dug up at the surface. And so I think it helps explain the whole process we're going through. So I brought the river in 4 times and I set a base height at -300, -600, -900. This one at the top is, I think, a few feet above. I think I set it at 5 or 10 feet because I wanted to get it on top of that polygon. Looks like I missed maybe a little. But you could maybe visualize if the river surface was a elevation of the river, the top of this polygon could be forced to fit it. We could tell the polygon that the upper surface is the river elevation. So it allows us to graphically demonstrate the entire project. You can see there's several places we're going to be digging all the way down to here to get these pods of contaminated area. Your analysis may be a little different depending on how you drew your river. You'll notice across the top we have the ability to do geoprocessing steps inside of this environment. We also have the ability under File Export to export a 2D, in other words, a snapshot of that. Of course, I could do a screen capture too, or a 3D. I can export a 3D graphics file, basically a virtual reality VRML model. And then there would be viewer software that would allow a person that does not own ArcGIS to open up this model and work on it, or look at it anyway to understand it. So that covers the topics I want to get to in ArcScene, this product. Thank you.